All right, we're on page 10 of the packet, and we're going to go ahead and do the race car example. Okay, so this race car example one, the reason I want to do this is it brings up equation 3, kind of an interesting fact when we solve for v because it's a squared term, and also how do we solve number 2 for t if it's a quadratic. So we're going to focus on those two kind of special situations, and we can do it all in this problem. So let's go ahead and start. A race car shifts from second gear at 15 meters per second and undergoes a constant acceleration for the next 200 meters of 3.2 meters per second squared. Now, whenever you see uniform acceleration, constant acceleration, we're just informing you that we can use these equations over here. We can use those 4 equations. So they told me the acceleration was uniform and 3.2 meters per second squared. The units really gave that one away. It said it went 200 meters. Now, it didn't tell me where it started and then where it ended. It just said it went 200 meters. So I get a choice. I get to choose. It starts at 0, ends at 200. Now, could I have said it starts at 100, ends at 300? Yes, that would be going 200 meters, but this is probably the easier way. It also tells me it starts out at 15 meters per second and speeds up to some final velocity. And so those are the 2 values we're looking for. We're looking for this final velocity and we're looking for that time. Part A asks us find the final velocity after that 200 meters. Okay, so I'm going to try and pick an equation to find v. So I'm going to look for my other unknown t. So I'm going to try and pick an equation without t. That would be equation number 3. So I have v squared equals v naught squared plus 2a times x minus x naught, crossing out the 0, so that is gone. And we're now trying to solve for v. Well, that's nice, it's almost done. I just have to move that square over to the other side. So in order to get rid of a square, I need to take the, you guessed it, square root. So v is equal to the square root of v naught plus 2a times x. Where are my math people at? What did I miss? What did I miss? Plus or minus. You are correct. And what is the plus or minus telling us here? Well, it's a velocity, so the plus or minus is telling us a direction. Well, since my car was moving in the positive direction and has a positive acceleration, so velocity and acceleration in the same direction, it must be speeding up. Yes, so I will be ending up with the positive value there. Okay, so now I can plug in my numbers. So I get the square root of 15 squared plus 2 times 3.2 times 200. And again, it is the positive value. And I get a velocity of 38.8 meters per second for that velocity. In meters per second, of course, so 38.8 meters per second. So they more than doubled their speed after that shift. That was pretty impressive. All right, so part B now, kind of, make the color change there for you. Part B asks, how long does it take for the car to go that 200 meters? So now I'm trying to find time. Now, if I use this v, it's pretty easy. I can just use equation number 1 and solve for t. But let's say we hadn't done part A first. What would we do if we hadn't done that? So we have this set up and we're like, well, we don't know v, we're not trying to find v, we're trying to find t. So I'll pick an equation without v final. Equation without v final is number 2, and I have x equals x naught plus v naught t plus 1/2 at squared. And so I plug this stuff in, crossing out the 0. Okay, now I end up with something that looks like this. 200 equals 15t plus 1/2 times 3.2 t squared. And so I have a term without t, a term with t, and a term with t squared, meaning I have a quadratic. So what I want to do is get that into a format that'll work. So I'm going to move this 200 over to the other side. So I have 0 is equal to negative 200 plus 15t plus 1/2 times 3.2 t squared. Now, for quadratics, if we remember the quadratic equation, great, you can do that. But what I'm going to do now is I'm going to go ahead and I'm going to show you guys Polysymbol 2. And so when we get to test time, if you get to a quadratic, you just have to type this and then write your answer. So what I'm going to do is I'm going to take a quick second and I'm going to show you a screenshot of the steps for using Polysymbol 2, and I'm going to walk you through it on the calculator, okay?
Polysymbol is under Applications. You have to scroll all the way down to the P's, so I'm going to hit Alpha P and find Polysymbol 2. If this is not on your calculator, I can transfer it to your calculator, so just come see me and we can put that on there. So I'm going to choose Polysymbol. I got to hit Enter a few times. We're going to choose the Poly Root Finder, which is option number 1. You're going to want a second order because we have a squared term. We want real decimal answers. We're going to keep it in normal and float, and our trig functions, we're not doing any, but we'll leave it in degree because we'll use that later. We're going to hit the next key. So how we hit this next key is we actually hit the key right below it, which is our graph button. Now I need to type in my answers here. So I have 0.5 times 3.2, which is 1.6. I have 15, and I have negative 200. Once I get those typed in, we're going to go ahead and click Solve, which is again our graph button. And it should come up with two answers, negative 16.8 and 7.4. Of course, we want the positive time.
All right, so now we got our answer. Polysymbol 2 is awesome. How about that? So we got two answers, and again, we want the positive of the two answers. So we got 7.4 seconds is the time it takes.